So, in the last class, we made a T-chart. Do y'all remember that? With population and sample. So let's go back to that really quickly. So we had our T-chart, and it had population in the left-hand side, and it had sample on the right-hand side. And so far we have put parameter and statistic, and we have put mean for population and sample. The next thing that we are going to add is what we call, when you have categorical data, the rule is I know something is categorical if it doesn't make sense to average. So instead of averaging the data, I'm going to find the proportion. So it's kind of like the percentage, but writing it in decimal places. So if I asked you what color car you had, 0.583 have a black car, something like that. Hunter used to have a black car. So
wow, that's another like.
So this would be considered the, I'm very sorry for that, the proportion. This is called the proportion. Population proportion I call P, and sample proportion I call P hat. Let's put a little hat on it. P hat? Yes, P hat. This is for proportions. I use these when I'm talking about categorical data, when it doesn't make sense to average them. But I use means for numerical data. So P hat is just the number of successes over your sample size. Do you need me to go back?
What?
I can't go back now.
What page is this on?
What?
This is on your the page that you're making your T-chart.
Oh, okay.
So what's the proportion of P hat?
P hat goes under sample.
It's just sample.
Mm-hmm. Sample proportion is P hat. Population proportion is just P. You use that for categorical data. Yeah. Looks like a little house. You see right here.
Sample proportion, and which one is for population?
Just P.
Which means what kind of proportion?
Population proportion.
And it's number of successes. Over what?
It's just like finding your relative frequency. It's the same thing.
Oh.
So relative frequency and proportions are the same thing. So the next thing we're going to talk about is variability. We have talked about center last class. Center was mean, median, and mode. Variability, we're going to learn all of the parts of variability today. So variability, remember, was it's in everything. It's compared to that example we talked about on the first day. If you buy Dr. Pepper cans, they're not all going to have exactly 12 ounces, so it's going to vary from Coke can to Coke can or Dr. Pepper can. It allows us to distinguish between usual and unusual values. So is the Dr. Pepper can that has 11.9 ounces unusual, or is it just because of variability? Well, if it's close enough, it's just due to sampling variability. If you had a Coke can that only had 4 ounces and it should have 12, that would be something that is unusual.
I'd sue.
You would sue. That's right.
For what? Like $1?
If you only report the measure of center, it doesn't give you a complete picture of the distribution. So that's why we cuss. Center, spread, shape, outliers. And this is why. So here we have distributions A, B, and C. The mean and the median of these graphs are all what? The same, and that number would be 45. So they're 3 different distributions because of the spread. So the first thing that we could report is the range. Yes.
What's the difference between spread and distribution?
So distribution is the whole picture, like talking about center, spread, shape. And then spread is just a part of the distribution.
You said the mean and the median are both 45?
So variability is just spread and cuts.
Mhm. So the first type that we talked about is finding the range, largest minus smallest. So you only report one number when you're talking about the range. You don't say the range is from 20 to 70. You say the range is 50. So the range for A would be 50, the range for B, and the range for C
Yes.
would be 10. So even reporting the range is not always the most accurate because A and B are still two different distributions, but they give the same range. So that's why we could report what we call the standard deviation, which we're going to talk about here in a minute, exactly what that means. But the standard deviation goes even further into talking about the variability. And the standard deviation is just the average distance from the mean. And you're going to have a worksheet today where you're looking at a bunch of distributions and then estimating the standard deviations just looking at a picture. So if I were to rank these by smallest standard deviation to biggest, and we're not even going to talk about any numbers, because there's no way you could look at something and say the standard deviation is 2 by just looking at it. Your calculator is going to do all the work. But you should be able to look at a picture and decide which one has a bigger standard deviation, which one has a smaller standard deviation. So if I were to rank these, C would have the smallest standard deviation because it is the most concentrated in the middle. Now when I'm choosing between A and B, B would be the medium, and A would be the largest standard deviation. The reason why is because these are equally spaced, and B has a higher frequency still in the middle and only 2 on the outside.
How are all the means the same for the averages and
Because they're all symmetrical. So when you have a perfectly symmetrical distribution, mean and median are in the center.
So not talking about the dots, they're talking about the...
They are talking about the dots, but if you counted all of those dots and divided by...
Okay, that makes sense.
If you counted all the dots and then divided by 6, you would still end up getting 45 exactly. And then since there are 6 dots, you take the average between the 2 middle ones on all of them. They would all be 45. If you had a distribution that looked like, I'm just going to draw on top of this. So this would be the largest standard deviation out of the 3. If I had another one that was a number line from 20 to 70, and I had 3 dots on 20 and 3 dots on 70, my mean and my median would still both be 45, but this would have the highest, like the largest standard deviation out of all of them. I'm going to use largest, because you have really high frequency on the tails. So the further away from the center your points are, the bigger your standard deviation is. So just kind of going back over to what a deviation is, and we did a little bit of this on the fish length activity last time, but a deviation is just a distance from the mean. The mean here is 45. Deviation is just finding the distance from them. If you averaged all of those deviations, we would call that the variance. This formula is not something that you need to memorize because our calculator does it for you, but this symbol right here is called variance, S squared. So this is going back to that activity we did last time, finding the deviations from this. Remember, some of them were positive and some were negative. They always added to 0. Remember, they always add to 0. If I were to try to find the average of this list right here, what would end up happening? It would be what? 0. The average of 0 is 0. And so you can't average these numbers because they always add up to 0. So in order to find an average by hand, like if you did it the long way, and also if you maybe took a stats class in college, they might make you do this by hand. Since they always equal 0, one way to make them all positive is to square them. Then take the average of that. So then the average, this is what variance is. If you don't want to know the long way of like why, then you can just tune me out. But essentially, you're taking all the deviations, you're squaring them to make them positive, you're finding that average. Then to find the standard deviation, you're going back and square rooting it again. So the average or the typical deviation from the mean is the standard deviation. The relationship to the standard deviation is the square root of the variance. So I want you to go back to your T-chart because we've got more things to add. So in our two lists, we have population and we have sample. We are now adding standard deviation and we're adding variance. Now the sample is going to be S, I'm going to use a different color, is going to be S and S squared. The population is going to be the Greek form of S, so it'll be sigma and sigma squared. And the way to draw this, mine are usually not that beautiful, but I kind of just make a little curly O. Looks like an olive almost. I'm not going to be too picky. Some people draw theirs like this. It's like a V with like a line on top. I'm not going to be too picky as long as you give me the correct notation. So I do want you to know that the relationship between these two numbers is that standard deviation squared equals variance, and the square root of variance is standard deviation. It seems intuitive, but standard deviation squared is variance, the square root of variance is standard deviation.
Wait, well, variance equals what?
Variance equals standard deviation squared.
No one's the other one.
Square root of variance is standard deviation. Square root of variance is standard deviation. So this is the formula. Remember I said that you don't have to have that memorized, but the reason why I show it to you is because of this denominator right here, the n minus 1. We call that our degrees of freedom. So if I said there was a sample of 40 students, and I said, how many degrees of freedom do you have? Then you would tell me we have 39 degrees of freedom. So let me write that down, and then let me tell you what that means, or why we even talk about it. So degrees of freedom are the number of independent observations that are free to vary. So I'm going to say, let's suppose that I chose 6 people in here. And I said, okay, you 6 people, Nick, you can be one of them. It is your job to take this test and make the average. I want your average to be a 93. So you 6 people have to make a 93 average. So that would mean that this plus this, all of them divided by 6 needs to equal 93. So person 1 through 5 take the test, and here's what they score. They score a 95, a 67, an 83, 100, and a
92.
92. Okay.
100.
Now, this 6th person doesn't really have a choice. The pressure is on that person, right? Because all 5 people went, and we could figure out what does that person need to make. In fact, I'm going to do that right now. Not the weighted average, just what that person needs to make.
There was there's a curve, right?
No curve.
Best under pressure.
It's AP grading, right? You see it. So we're at 5, couple of 4.
So that person has to score a 121.
Oh.
Is that even possible? No, it is impossible. So they screwed it up for everyone. Hypothetically, what that means is if I have 6 people in my sample, I have 5 degrees of freedom. 5 people that are free to make whatever they want or do whatever they want. But that 6th person is fixed, a fixed value that makes the average and or the standard deviation be a fixed number. So if I had a sample size of 6, which I call n equals 6, then how many degrees of freedom do I have? 5. Good. So that is all that I mean by degrees of freedom. In the simplest terms. That person has to make 121.
Yeah, who No, Nick.
The last type of variability is called the IQR. We talked a little bit about that in the cumulative relative frequencies.
Oh, the 75%.
So it's the 75th percentile minus the 25th percentile.
Will it always be at 100?
Do what?
Well, like, you have to make sure if it's out of 100 then you do that.
It doesn't have to be out of 100. It has to be out of 100%, but not 100 people. Yeah. So it's just the range of the middle half of the data, the middle 50% of your data. And once we start constructing box plots next class, you'll kind of see more of that. So what I want you to do now is go back to your T-chart. A little bit underneath it, we're going to start a new little chart. So skip, I guess, to the bottom. It's not completely done, so leave a little space. And we're going to talk about measures of ... center and variability. This is just on the bottom of your T-chart page. Measures of center, measures of variability.
T-chart's not done though?
No, we've got a little bit left. Making another T-chart. So measures of center, there are 3. What are they?
Mean, median, mode.
Mean, median, and mode.
Boom. Wow, Chaz.
Wow, good job, guys.
Big chat.
When we cuss, what are the 2 that I would report, and what is the one that I don't report?
Mean, median, don't report mode.
Yeah, so I report the mean, median. I don't report the mode at all. It's just kind of there, but it's irrelevant. Now, when I'm talking about being resistant or not resistant to outliers, which one is resistant? Median is resistant. That means that it's not affected by outliers.
Strong will.
So if I have a distribution and I've got an outlier out here, this guy is an outlier. That affects my mean, but it doesn't affect my median.
Wait, why would you? Chaz wants to for the test. Good.
I thought resistant meant
In the
loss.
quizzes.
Can't do it on like a class box.
So when I have skewed data, I want to use the median when I'm cussing. So use when data is skewed to cuss. Measures of variability, we now have range.
Can you just use it whenever, though?
I would use it all the time if I were you, but
Use what?
What?
the median.
Just
Just always
we
use
can
the
always
median.
use the median?
Yes.
Okay, good.
But the reason I say that is because I guarantee you this shows up every year. There will be a question that says, why should you report the median instead of the mean? You say it's resistant and you have skewed data. So, variability, we have range, we have standard deviation, we have variance, and we have IQR.
You didn't actually do it. Don't know left.
I'm gonna ignore that.
Rose challenged me and said I couldn't.
I did not challenge it. I wanted
Rose, why would you do that?
So
What if you drown?
No, I heard Rose say that. She was like,
If I were talking about which of the following were resistant or not resistant, is the range going to be affected by outliers?
Yes.
Yes.
Yes. Is the standard deviation going to be affected by outliers? Yes. And so then if this is affected by outliers, then so is variance because they go hand in hand.
But IQR is not.
But IQR is not. It is resistant because it is the middle 50% of the data. So my IQR in this would be like these people right here. No, nothing to do with outliers.
Not even like a.
So you would want to report the IQR when data is skewed.
So can we just use it all the time?
You can always use it. However, if you're writing out a cuss for me, you can use range all the time and it's never going to be wrong. I always use range and median. If a question comes to you and says, should you use range or IQR in this data set for variability, you would say IQR because it's resistant.
so
However, the AP test always accepts range and median no matter what.
So range can technically always be used.
Yes.
Like for sure, always.
Like
Can for sure
100%
always be used 100% if you're writing out a cuss. But if a question says which one should you use, then you need to say IQR.
Interquartile range.
Does that make sense?
So IQR is like.
But you can use IQR for either as well.
Yeah, you can always use IQR. It's just harder to
So
find.
any variability, say IQR.
Mhm.
Center, say median.
Yep.
Like, why can't you just say like
Why
middle 50?
is it like
Because it's the
variation?
inside
Why are we trying
quarter.
But don't like say
That's what we do when you describe a distribution. So the center spread, then you're going to talk about the shape too.
Average change.
Okay, I'm going to skip this because we're going to do this later and I don't think you need to do it by hand. So let's go to, I think it is page...
Do you please send Hunter my call to
Okay, from here, I want to go to stat, edit, or stat calc, enter. I should have nothing in my frequency list, so if you still have something from your last assignment, then you clear that.
how do you like change it?
Hit clear. Oh, you want to change it to a different list? I'll show you in a minute. Hit calculate. My mean is 1700. Why does it have a mu next to it on the paper though?
Because it is
Because it's numerical. It thinks
Nope.
it's numerical.
Nope.
it is
I don't know.
categorical.
Notation.
Nope. Notation for what?
Mean of population.
Mean of a population. So it is mu because it's a population. The company has 14 employees. I have all 14 data points. It is a population. Now, for standard deviation, I have two options. So you don't ever use this, you don't ever use this. These two are the standard deviations. The first one is for sample, and the second one is for population. You can tell because of the notation. Your population is always going to be smaller than your sample, and I'll show you why. You don't have to know the formula, but the formula for sample standard deviation is the square root over n minus 1, and then the population is the same thing over n. So My two formulas are different because of the denominator. The sample is always going to be n minus 1. So in this case, 13 would go on the denominator for sample and 14 would go on the denominator for population. So that always means that my population standard deviation is going to be smaller. The reason why we do this is because if you have the exact number of your population, you get the exact standard deviation. If you have a sample, you're just estimating it. It's always going to be bigger because you want to give yourself a little wiggle room, a little bit of degrees of freedom. So give yourself some freedom to a little margin of error. But when you have your population, you don't need to guesstimate. Yes?
Are you using the calculator emulator, or are you actually using your calculator and like projecting its?
No, it's software on my computer.
Dang it.
So we would write this down for population standard deviation. From here, the next thing that it says business has been good, so every employee is going to get a raise of 500. So I'm going to go back to stat edit. Instead of changing these to add 500, everyone look, I need your focus. You're going to go back up, highlight L2, and you treat it just like you would an Excel formula. So hit enter, and you're going to see a blanky square. Then I'm going to type in L1 plus 500. So to get L1 to show up, I hit second 1 plus 500. So I hit enter, and they show up. From here, now I'm going to do stat calc enter on L2. I hit second L2 or second 2.
Wait, can you go back?
Yes.
It's still the same for the O number.
What did you notice about the mean? It went up 500. What happened to the standard deviation? It stayed the same. So then the next one says business has not been good. We had to cut everyone's pay by 100. So imagine each one of these scenarios is stemming from the original. So if I'm starting with the original, which the mean was 1,700, if my business goes down and everyone gets a $100 pay cut, what do you think that the new mean would be? 1,600. That's if everyone lost $100. What do you think the standard deviation would do? It would stay the same. It would still be 603.56. So when you are just adding or subtracting a constant, so I'm going to erase all this, go down to the rules part. So the rules part of the page, when adding, subtracting, constant. Yes. The mean changes. So plus or minus the constant, whatever that is. The standard deviation stays the same. The reason why, just to kind of visualize that for you, it's like if I gave everybody, so here's my distribution of quiz scores, 50 to 100. And they look something like this, something like that. There we go. So here's what my quiz scores looked like. If I gave everybody a 10-point curve, all that would do would pick up your data, move it over 10 points, drop it back down. So these would change to 110 and 60. My range doesn't change, so therefore my standard deviation doesn't change. It just picks everyone up and moves you over plus 10.
And which one is that for? I mean,
That's when you're adding and subtracting a constant. So the mean does change. The standard deviation stays the same.
What is standard deviation? Like,
It's your average distance from the means. So your distance from the means doesn't change if you're just adding or subtracting. It's like sliding them on a x-axis. So let's go back to the calculator because it says now we're going to double everyone's salary. So I'm going to go back to stat, edit, and I want to take my L2. I'm going to go up to L2. I'm going to hit enter. What formula would double the salary? 2 times L1. Yes.
You're using the orange.
Original. You don't have to, no. From there, stat, calc, enter. So what happened to the mean and the standard deviation? So what happened to the standard deviation? So they both doubled. So then the next question says, suppose we give everyone a 30% raise. What do you think is going to happen to the mean and the standard deviation from there? Times 1.3. So my original was 1,700 for the mean. So 1,700 times 1.3. The standard deviation was 603 point something. I'm going to multiply that by 1.3. And that's going to get me my new mean and my new standard deviation. So what do you get?
2210.
And then what about the standard deviation?
7834. But I put the points.
Okay, that's fine. Because you're giving them a 30% raise. So you're increasing everyone. So it's 100% plus 30%.
They're already getting 100%. And then they're adding that 23%.
So what do we think the rule is for? So go back down to the rules part. When multiplying by a constant or percentage. So mean and standard deviation will change by that multiplier. So they both change. This is technically called the linear transformation rule. These are just the rules written in words. I want you to write at the top, this is when you have one set of data. So when you have one set of data, one list, and you're adding, subtracting, multiplying, dividing to it. Do what? Univariate. They're all univariate, just how many sets of data you have. We haven't done anything bivariate yet. Okay, here's an example of something you would see on a multiple choice question. So an appliance repair shop charges a $30 service. It also charges $25 per hour for labor. So from past history, the average is 1.25 hours and the standard deviation is the third hour. So what is the mean and standard deviation cost of the charges? So the first thing you have to do is create an equation based on so I want to figure out what is the total cost. It's $30 plus $25 per hour. Or you could say times time if you wanted. It doesn't matter, hour. You could even use X and Y. No one's going to look at the work. But your average time, so my average time is 1.25, and my standard deviation time is 1/3. So I want to take these numbers and I want to find the average cost and the standard deviation cost. So essentially I'm taking these numbers, I'm multiplying them by 25, and I'm adding 30. So for mean, it's really easy because I'm just going to plug it in right here. 30 plus 25 times 1.25. So your average cost is going to be I don't know. $61.25. But for standard deviation, this 30 does not matter because it's adding a constant. So I'm only going to plug it into the 25 times 1/3. Because adding and subtracting a constant does not matter. Because adding the 30 doesn't change my standard deviation. So when you have a multiple choice question, one of the choices will be 833 and one of them will be 3833. So don't make the mistake of choosing the wrong one. When you add or subtract a constant, standard deviation doesn't change. Yes?
Well, what does the 833 mean, like the question?
So the average cost for this labor is $61.25. And then the typical deviation from that is about $8.33. Yes.
Including the charge of the service call.
But that's not deviation.
Yeah, that's not deviating.
Because it'll only go that
Mm-hmm. So once we get into normal curves, it'll make more sense. But essentially, your average is going to be here in the center. If you add $8, subtract $8. It's not the total range, but you have the highest frequency within $8. 53. I don't know. Whatever 8 is minus that. But this will make a lot more sense once we start doing normal curves. Who's excited to play some Statland? It's the most fun game in the whole world. No, Reese loves this game. Reese, if you're listening, we're playing Statland. Yes, he loves this game. Okay, turn to page 63. Nope, we play it once. Today. So from here, list all of the possible sums of the two spinners. So I'm just going to list out all of the combinations. I could do 1, 1, 1, 2, 1, 3, 1, 4.
2.
Okay, so for the first one, it wants you to list out all the sums. So you should put the 24 sums into a list.
Those 24 sums
Okay,
you know
now do 1 var stats on those sums.
Okay.
I'm way ahead of you.
Do what?
1 var stat, like stat calc enter.
Yeah, I did.
Find the mean and the standard deviations of the sum.
Oh, I hit something on my ink. I forgot.
I'm gonna have to erase mu, sorry.
No.
I know.
12 minutes left in class, yay!
That's a positive.
Get
Okay.
here.
What was the average of the sums? What was the standard deviation of the sums?
2.04.
Okay, now the purple numbers are all the differences.
I'm just gonna copy that.
Okay,
Differences from what?
the possible outcomes of the two spinners. So if I rolled a 1 and a 1, the difference would be 0.
Why
If I
would-
rolled a 1 and then a 2, the difference would be negative 1.
So, are we just plugging those in now?
Oh.
So you're plugging in the purple
Why is
numbers
difference negative?
Why? In what?
because it's A minus B.
Has to be.
Oh, so you get
Yes.
1 minus 1, 2 minus 1.
Uh-huh.
No. Wait. You just go backwards with it?
Yeah, you're just doing like A minus B.
No.
So 1 minus 2 is negative 1. 1 minus 3 is negative 2.
So why does it say the no, it's cold.
So in your calculator, do you have to put negatives?
Yeah.
You said? Why
So when you put these purple numbers into your list, like when you put all the differences in a list, I want to find the mean and the standard deviation of those numbers.
The difference is this with the curly thing?
No, I just subtracted. Okay.
Or should I get later? Shows 8 answers. Here.
So why are the standard deviations the same? The means are different. So let's talk about the means. When I combined them, What do you notice about the similarities between these two numbers and the combination?
They're both positive.
Approximately in the middle.
It's not in the middle.
Game.
I said approximate.
When I take 3.5 and I add 2.5, I get 6. When I take 3.5 and I subtract, I get 1. So when the means, when you're combining means, you either add or subtract them. The standard deviations, you get a weird number that I'm about to show you how you get them, but they are the same whether you add or subtract them together.
Because the difference between
We could have just,
same.
so to find the mean, you just add or subtract the two means together. That one's very simple. But to find the standard deviation, you're gonna take each standard deviation, you're gonna square them, add them together, square root. So you're gonna add the variances, essentially. Yes, you do have to have this memorized. I would circle, highlight, star this slide because it shows up a billion times between now and the AP test. A billion.
But
Yeah.
why would you need to do that?
If you're combining, so this is for 2 or more sets of data. If I'm combining 2 sets of data. So if I said like the average test grade for boys was a 73 and the average test grade for girls was an 85. What is the total? It wouldn't make sense for that necessarily is like if you're wanting to combine 2 sets of data. Like if I said, what's the total time it takes you to get ready in the morning? It takes you 30 minutes to get out of bed and 10 minutes to brush your teeth and 20 minutes to drive to school. So you would combine all of those averages together.
And no breakfast.
So we have to
in there?
memorize which part?
That is very unhealthy.
You need to memorize all of this.
Highly unhealthy. Me?
So here's an example of what kind of question you would see. So bicycles arrive at a bike shop in boxes before they can be sold. That was the game.
That was an awful game.
That was the best
You
game.
got me excited for a game, and now it's like, that was the game. That was the worst.
That was the best
There's
game.
more minutes.
Can we watch Flatland?
No. Okay. Last thing. We're almost done.
Oh, she's a Teddy Flatland.
What's flatland?
So it is asking for the total bicycle setup time because you have to unpack, assemble, and tune the bike. So I want to combine all 3 of these averages. So for the mean, the total mean, I'm going to take 3.5 plus 21.8 plus 12.3. And that gets me 37.6 minutes. So the total bicycle setup time is just adding them together. The standard deviation, I'm going to square root 0.7 squared plus 2.4 squared plus 2.7 squared. So I'm going to take all of my standard deviations, square them, add them together. Is that your head? I thought something was going on out there.
Someone was like hitting the wall. I was getting annoyed.
So you're going to square these, add them together, and square root the whole thing.
Sounds really cool.
No.
You're gonna hurt your head, and then
What is
you're
this
gonna.
square?
I got a thicker skull than that. I'm not hitting that.
You square root it.
Okay,
So you
thank
square them, add them,
That's
square root
all I
them.
know.
And that gets you the total square
And
root.
you like
Get shattered.
Square them?
That doesn't cancel out though?
Mm-mm.
yeah.
Plus there's just one of them though.
What
If there were just one, yeah.
And then you couldn't swim.
So it's 3.679.
You said I couldn't walk. You never said I couldn't swim.
So what I want you to get from this, everyone, I need your last focus for a second. No matter if you're finding the combination of means or the difference, like you're subtracting, you will always add the standard deviations. Always add. So in all caps, I want you to write on your page, always add the standard deviations or the variances.